All right, welcome everybody. Welcome to today's session on industrial IoT cybersecurity from the shop floor to the boardroom. My name is Lucian Fogoros, and I'm the co-founder of IoT World, and I'm here supported by my team, Carolina and Greg Orloff, who's the Chief Innovation Officer. And we have an exciting panel today with three speakers, and then you'll have the opportunity to ask your questions around the panel discussion. For those of you that do not know about IoT World, we are a digital media publication that covers the economic and technological implication of the transformation taking place as industrial IoT proliferates throughout the enterprise. We combine journalistic coverage with data analysis to expose the stories, players, trend, and innovation that shape the industrial IoT. IoT World was recently ranked by Kcore Analytics as the #1 global influencers on several topics that include industrial control cybersecurity, SCADA, predictive analytics and predictive maintenance, as well as industrial IoT and smart manufacturing. IoT World's mission is to help companies create a culture of innovation and connect the smart industrial technology, manufacturing, sensors, and CSO decision makers. Today we have an exciting panel representing companies such as Cisco, Trend Micro, and Adalis. We're going to start a session around the industrial cybersecurity. Eric Byers, the CEO of Adalis, will be opening that with a session titled "It's Time for Strategy, Not Tactics," around the industrial control cybersecurity. Then we have a representative from Cisco that talks about how to evolve your plant security from today's reality to tomorrow's connected factory. And then we'll hear from Trend Micro around best practices and cybersecurity for operational technology environment. And then, of course, you'll have your questions. Either you can post them on a chat or via the Twitter or LinkedIn using the hashtag ICS_IIoT. We already received several questions, so we'll do our best to respond within the live session. We're also going to carry this conversation around various social channels. So again, we will open up the conversation with Eric Byers, who is the CEO of Adalis. Eric is an expert and visionary in the field of SCADA and ICS security, experience in controls engineering, security research, in corporate management. He offers a unique blend of deep technological knowledge and practical business experience. Eric is probably best known for inventing and successfully commercializing the Tofino firewall, the world's most widely deployed ICS security appliance. Tofino technology has received numerous industry awards and is licensed by industry giants such as Honeywell, Schneider, and Caterpillar. I've often heard of Eric referred to the father of ICS security. Welcome, Eric.
Well, thanks. Thank you very much. It's a pleasure to be here. And yeah, I want to talk today a little bit about how I'm seeing the market change and the environment change for everybody who's involved in ICS or industrial IoT security, and why I believe that we need to move more to strategy and not tactics, and how we've been focused on tactics over the last few decades since this started. Next slide. Back when I was initially working in cybersecurity back in the early 2000s in control systems, life was actually a little simpler. There were less attacks. Nobody was paying any attention to it, so it was hard to get anybody's interest. But you know, the attacks and the issues that were coming up were largely little complexity, very opportunistic, very noisy, and often in the case of something like Slammer or Sasser or Zotob, those were being caused by IT malware, and they were just collateral damage. And then through late 2000, 2009, 2010, we started to get to much more complex attacks, including things like Stuxnet and Conficker, where there was clearly system knowledge, where it was sometimes insider driven, sometimes not. But there was clear intent, you know, Stuxnet, Dooku, Gauss, Shamoon, those were all definitely being driven to impact control systems. So we were no longer just collateral damage. And then in the last say 4 to 5 years, we're starting to see a completely different type of attack against our control systems. We have Dragonfly, we have the very focused 2 Ukrainian power outages, we have the Triton attacks against safety systems in the Middle East, we have the recent announcement of the penetration by Russian operatives into the US grid. These are completely different. These are multi-stage, multi-tooled managed processes. They're professionally organized, and they have, for example, the US grid attacks, there's no real attack there, they're penetrations. Somebody's playing with a long time horizon and it's trying to stay under the horizon. So this is somebody, our attackers are not just trying a trick and seeing if it works. We're not just seeing a kid in Montreal being surprised that he got into a website and having fun. We're having somebody who's running a professionally strategic operation for long-term gain. They want to get into a control system, and they want to stay there for decades, if necessary, under the radar, so they can either mine data, impact operations, or do some catastrophic operation when the time is appropriate. So clearly, our attackers, the people or our adversaries, are being strategic. They're not just saying, hey, I see an opportunity, I'll go take it. They are trying to understand who we are, what our operations are, and what your operations are if you're an operator of an IIoT or ICS system, and how can I manipulate this in a way that's advantageous. I mean, nobody's attacking for fun anymore. They're doing it for political reasons or profits. So next slide. So the trouble is that the ICS and IIoT security market has stayed very, very strategic. It's very, strategic tactical. It is very interested in the weapons we're going to use. It's very interested in defenses. Now, as a guy who sold firewalls, this is terrific. Okay, you just buy my firewall and install it, and life will be good. And this model, while the firewall may be very important, it has to be part of a larger strategy. Next slide. So basically, we're in the middle of a conflict. We're not just in the middle of an accident. This is not, you're not going to have a control system, particularly if you're in the energy or oil and gas sectors, but any critical sector. You're not going to have attackers who are just going after you because it's easy. They're going after you because they have a strategy to go after you. And you're in the middle of a conflict. They want to get goals that are in opposition to your goal of running a safe, reliable, and profitable operation. Now, there's been lots of research into how to win direct conflicts. Long conflicts or slow conflicts. One of the best ones was developed by Colonel John Boyd, a U.S. Air Force fighter pilot who was exceedingly good fighter pilot during the Korean War. And he developed something called the OODA loop. Observe, orient, decide, and act is what it stood for. And he developed this formal process that he believed, and many people in the military now believe, really defines what you have to do to win a conflict. Now, I'm not going to go into the OODA loop. I do talks on it all the time. I think it's a terrific model for figuring out what you're going to do. But I do want to talk a little bit about what Boyd said, and that was, you want to focus on building your best mental vision of what that best mental concepts possible to win the battle. Okay, so if we want to move away from being strictly tactical, saying, oh, I've got a problem with passwords, I'm going to put in a new password management system. Oh, I've got a problem with traffic coming into my network, I'm going to put in a new firewall, and you're strictly worrying about the tactics, you want to get out of that mindset and into a long-term strategy, you need solid mental concepts. And you need to understand what your system is doing. What is your environment? This is the first thing. You can't, and the second thing you need to do is you have to understand your enemy. We have to understand what their likely behaviors are. And in any control system, cybersecurity system for control, we end up collecting a lot of data and a lot of assumptions. We need to be able to organize those so we can really take timely and intelligent actions. Next slide. Okay, so let's talk about that first required concept or model that we need, and that is, who am I? What is my environment? Unfortunately, what I see when I go out to visit companies is many companies don't have a complete integrated inventory of, first of all, their assets. They may have the major assets. They may, for example, have their distributed control system from a major vendor. All the components attached directly to it are well documented. But then as soon as you get outside that into drive controls or into analytics controls or new IIoT equipment or their switches and network equipment, suddenly those assets are fuzzy. They're less clear on that. You need a complete inventory of your assets, not just your primary control system. And with that, you need other information as well, like what software is actually deployed on that, what version, what patch level, and how is that software, its status versus the outside world. You know, are there known vulnerabilities in that software or firmware that's installed in your PLC? Okay. I'm not saying you got to fix them. You know, people say, oh, patch early and patch often. I'm saying understand it first. Okay, I've got a bunch of old PLC 5s. What are the vulnerabilities in the firmware and PLC 5s that are 15 years old? Only once you start to understand those will you be able to later understand how you might protect them, possibly upgrading them, possibly not. But you'll be able to build an idea around how you protect them. But also you'll know that that may be something your adversary focuses in on. So getting that understanding of your assets, the software that's deployed on it, and the quality and condition of that software, your backup states, and in fact, the asset health and activity going on with every one of those assets, who's logging into them, who's using them, etc. That's all critical. Very few companies do that well right now. They'll do little bits and pieces, and there's actually relatively few products that really give you that integrated picture. Here's a screenshot from one company. Go to the next slide. And you can see that it's not trying to be a whitelisting company or an alarm alert company or anything like that. It's an aggregation. They're aggregating all the possible information that you can have into one spot so you can understand what is happening with that piece of equipment in the larger context. So it's absolutely critical that we get a better understanding, a model, as Boyd would call it, of what our environment is doing at any particular point. Next slide. The other thing is we have to understand the attacker behavior. It's not just good enough to say we've got attackers. And you've probably heard of the kill chain model. It is not the perfect model, it's just a model, and any model is better than no model of what attackers do. They typically start off doing reconnaissance, then they'll do what we call weaponization, in other words, preparing a tool to attack and targeting, then they'll deliver that into an organization, then they'll do the exploits to take control, then they'll start to install and modify the platform that they're sitting on, be it a desktop or controller, so that they can communicate and use it in a way they want, and then they'll start to communicate back, and then they'll act. And often the act is move forward. Just, okay, I got into the receptionist's computer, now I want to get to an engineer's computer. Maybe my action is, I've got to an engineer's computer, now I want to get to a PLC. If you look at something like Stuxnet, it followed this absolutely beautifully, working its way down this repeatedly, following these kill chain models. Now, what is this? Well, actually, let's go to the next slide. What we see is in reports of attacks, and this one came out of the Ukrainian power outage, it's a screenshot. Every one of these analyzed attacks fell into a kill chain. What's sad is that people don't do this in the plant when they're under attack. They do it 6 months later. There was lots of indicators during the Ukrainian attack that if people knew to look for them, they would have realized that they were about to have a problem. And that's obvious in hindsight, but what we really need to be able to do is to do that up front. Let me give you a very specific example on the next slide. We have a firewall event. A packet gets dropped, and its source is some source outside the network and some source inside the target inside the network, and it's port 502. Okay, well, it's port 502 leads me to believe it's Modbus. The fact that it's from outside to inside, that's very interesting. And I've dropped it. Okay, but what does that indicate the attacker is doing? Is he trying to deliver a particular payload? Is he trying to execute a particular exploit? Is he trying to actually modify a controller? If you don't know what that particular event signifies in terms of what your attacker's doing, you don't know how to respond. And this is absolutely critical. For example, if it's just early reconnaissance, he's just pinging PLCs, you'll have a very different reaction to, oh, that packet was something to do with installation and modification of a PLC. For all of you out there who have PLCs, I know you're going to be far more panicked over somebody modifying your logic than you are just somebody discovering your PLC. So you need to understand what a particular event signifies in the model of how your attacker is going after your system. What does it mean? And this is really important. Next slide. So before you add new technologies, when you're evaluating them, and there's lots of technologies out there and lots of solutions, look at what new data this will be introducing into your system and into your operations, and then very quickly understand and focus on, is this helping me build up a model? Will this information improve my understanding of my situation or my adversary's behaviors? And with this is, how do we integrate that data to make it timely? You're always running within a very tight time frame when you're responding to some sort of event. How do we make our data into allow us to do a timely response? Next slide. To sort of close out and move on to the next section of our talk today, Boyd had an expression. He said, if you've got one doctrine, one model, you're a dinosaur, period. What he was trying to say is that you have to be flexible about what you see is happening. But really, I think it's more serious than that for us in the industrial control systems. Next slide. Do we have any model of what our attackers are doing? Do we have any concepts? Again, this is really important. We don't want to be dinosaurs. The bad guys are definitely building an understanding about us as they attack us. What is our understanding about the bad guys? So as you go forward, think about that. How do you understand the bad guys and how do you learn about them? And what are the tools and technologies you use to get that to occur? Thank you very much. Last slide.
Thank you, Eric. And a lot to consider as you build out your cybersecurity routine. And the next section, we're going to have Robert Albach from Cisco, who's going to talk about how to evolve from your plant security from today's reality to tomorrow's connected factory. While Robert is going to share his slides, I'm just going to briefly talk about his background. He's the product line manager for IoT Security for Cisco Systems. He's responsible for industrial security planning within the security portfolio. He has joined Cisco in 2010 when he defined and delivered 3 network security solutions with the most recent Cisco's first industrial security appliance. Prior to his tenure at Cisco, he guided the IPS management solution and low-end IPS solutions for intrusion prevention, pioneered Tipping Point. Outside of network security, Robert has led product management efforts and in the application management space at IBM and BMC, as well as Quest Software. Welcome, Robert.
Thank you, Lucian. And First, let me just confirm you folks can see my screen well enough, secured path forward.
Yes.
Wonderful. All right. Thank you very much. And Eric, I appreciate the intro that you gave. I think it's a very nice thought model that you presented, the idea of really focus on a strategy perspective. What I'd like to talk about today is a question that we receive frequently, which was, hey, great thoughts, good ideas on what it is that we need to be considering and so forth, but how do we get there? I mean, because we're in very different states of maturity with regards to our security state, even with regards to our operations themselves, and of course the underlying network and compute platform. So how do we move things forward? And a lot of the rationale behind that question is because, gee, we're being told we're supposed to become part of this grand industry 4.0. And I'm going to call it 4.0 for those of you who don't like the 4.0 perspective. And we're inevitably looking at this model, and the model says, all right, I've got things. I've got a lot of things that are in either different stages of age, modernity, different verticals that we're working with. And these things are in the midst of some process to create some kind of output. Maybe I'm creating peanut butter, maybe I'm generating electricity. I'm based in Texas, so naturally we're going to focus on things like I need to pull a bunch of natural gas out of the ground and I need to ship it far away to someone who can make use of it. But the story that you keep hearing over and over again is I have things. These things are critical to some form of process. And the better my process operates, the more likely my workforce is going to be safe, and the more likely that we're going to have continuation of those processes for greater profit. How are we going to do that? Well, we're going to start sharing data, and we're going to start sharing data from that process state up to our control areas. Been happening for decades already. For some people, we're moving this up to our MES and ERP systems. And increasingly, gee, we've got to get stuff all out to the cloud, also known as somebody else's server. So that's the big story. That's where a lot of the pressures are coming from the top of the company to say how we can improve things. But to do that, we're going to have to cross a bunch of boundaries. Now, one of the models that's out there is the Rammy model, and this is basically written up by, no big surprise, a group primarily based in Germany. And it describes, I think, a hybridization of two standards, the lifecycle value stream, 62890, and the hierarchy levels that we've known in the past, 62244, 62264, and they're like. What I really like about this particular model is that clearly it's talking about the different divisions within the organizations that make things happen. But probably most important to me in that lower left area, it actually points to the product itself. In other words, we can't sit there and assume that security of a process is limited to our floor space on the factory, if you will. There are inputs, and those inputs, essentially raw materials in some cases, or in other cases, it's other people's finished products that come in to the process. And at some point, that process is done. We have what we think is a finished product, which may in turn become part of somebody else's product, or maybe it's the done thing itself. The point being, we need to look at this in a more broader sense and consider, after this product leaves our factory, do we have other obligations to maintain it? Is it possibly going to come back in? Do we see value/revenue streams that are going to continue outward? And if so, we need to consider, again, broadening our view of what process means and also what it means to secure it. There's increasingly a lot of focus on the supply chain upstream of us, but we also need to start thinking about things downstream as well. All of that assumes that there may be some amount of information, telemetry, if you will, that we're going to be able to gather in this whole continuum, before the raw materials or subcomponents come into the factory, the time in which they are within the factory or process environment, and then the time in which it leaves. Now, this doesn't apply to everybody, but again, I want to broaden the scope of the discussion to that before we see the content, during the time that we act on the content, and after the point it leaves our particular factory, and what we might actually derive out of that moving forward. So to make this happen, we're going to have to cross a lot of organizational boundaries. And if there's anything that we find repeatedly over and over again in our engagements at Cisco is we are dealing with people in different organizations who have different perceptions of what's critical, and certainly different perceptions with regards to what security means. So the classic boundary is everything to the right is the factory. Everything to the right of that green line is something that I don't want IT people involved in, stay away. To the left, okay, I've got the enterprise and eventually the cloud. So here's the big purple box. This is the factory. No IT people allowed. My father-in-law used to build chemical plants on a couple of continents out there, and he was king of his kingdom. And frankly, he barely tolerated the people from headquarters from even showing up, let alone those IT guys. So of course it was rather disappointing when his daughter married me, but that's okay. You know, she was a chemical engineer. Between the two of us, we had pretty decent production. But these other areas out there, we've got the enterprise group. And again, in some cases, we've got a bit of an adversarial relationship between the people at the plant and the people back at headquarters. And then we have the people that are outside our company. Again, yet another group or set of groups whom we may have varying degrees of dependency on. And to make things happen, we're frankly going to have to work together. So moving forward, let's think a little bit about technology boundaries. Now, again, we've got our green line to the left. That's the others from the factory perspective, and to the right, the factory itself. And what we're going to see, though, is that what is the technology that's truly unique to these operational spaces? It's largely confined to these cell machine level environments. Now, of course, again, being in Texas, we're going to think about distillation columns and the like. But basically, what's the bits that are really unique within a technology spectrum for an operational space? And we're going to say, just for the sake of argument, well, it's primarily limited to that floor space and in the cells. Now, if we start saying, well, what does an IT technology stack look like and where is it present? We see this extending across that green line into the factory control center as well. What type of technology does S7 run on? Factory Talk, Ovation. They're Windows boxes. They're running .NET applications with maybe ASP interfaces, and Microsoft SQL Server is the underlying data repository. There's nothing uniquely OT about that technology stack. But part of the challenge is, of course, is that this IT technology is pushing deeper and deeper. Increasingly, all these PLCs are connected via TCP/IP, and for varying reasons, someone decided that would be a great idea to slap a web interface on top of some of those things there. So it's not that we're displacing OT technology per se, but we do absolutely see technologies that are traditionally associated with IT spaces pushing deeper into the factory floor itself. All right, so now we start coming to these other questions along the lines of, gee, what is security? How does this fit? Because if you haven't heard this before, understand that security is a process. It's not a product. Now, naturally, working at Cisco, we think we've got products that need to be applied, but the bigger point more than anything is, if I look at this technology stack from an organizational perspective, who is in the best position to actually work with and secure those particular assets? Now, my wife's got a chemical engineering degree. At no point did anyone during her education tell her how to manage a Microsoft SQL Server instance. How do we back it up? How do we do replication? How do we restore it in the case we happen to lose continuity and operation of those instances? So who does understand that area? And are they welcome within that factory space? Again, these are organizational challenges which we think are largely problematic to some of the events that we happen, particularly what happened last year. What shut down Merck Pharmaceuticals? What caused service interruptions at Maersk, Federal Express? They were basically all Windows class issues. They were basically Windows vulnerabilities. Didn't touch a PLC, didn't touch a sensor, never touched a robot. Once you lost control of the control systems, you have to shut things down. And that shutting things down is part of that process. In this case, security itself, making things more secure in both a safety perspective as well as from an external threat perspective, becomes part of the process. So what is it that we see here? And we basically advocate very closely a phased approach. Depending upon where you are in your maturity process, you may want to start at one point or another. No surprise, we're Cisco again, we look often at the very infrastructure of the environment itself. This is the first phase, and I often ask, what does the network look like? If the network is modern, if we're using infrastructure which in and of itself can apply some form of security, that's good stuff. But often enough, we'll see a highly fragmented, frankly, unarchitected network environment, which is not truly resilient in design, nor is it necessarily defensible. So we look to modernize the network, multipath, hierarchical in nature, provide the proper segmentation, and have controlled access to the different environments that are in place. So the big point here is purposeful network design. You can only see and control what the network allows. If you want to discover things in a certain area, if your network won't allow to gain access to it, then that's a problem. And you won't really understand what the potential vulnerabilities are for those particular pieces there. The second stage is where we start to look at a deeper set of visibility and control. And in this case, we like to emphasize the different sort of overlay in this concept of segmentation, and has to more to do not so much with the network physical topology, but the application topology itself. Because understanding what the applications are doing, who's talking to who, and potentially acting on explicit threats in the form of vulnerability exploits, this is the point where we have to look deeper into the traffic to understand what's happening. In some cases, this type of visibility and understanding will drive some of the virtual segmentation that's necessary to ensure that only the right applications are talking to the right assets in these environments. So the normal segmentation that begins is, gee, I want to be able to control access to an asset, not lower right, here's the robot, I want to be able to control access just to that one element in this particular cell. Or I need to separate this particular cell from the others, that's the next bigger gold box around that in the lower right. Or, gee, it's the entire plant floor that needs to be segmented. And then, of course, there's the I need to segment the factory from the rest of the enterprise network, if you will. Varying levels of segmentation. If you want to control access to a thing or a set of things, you need a control point, possibly a port switch or a gateway switch at the head of a machine that's capable of doing these types of things. These are the types of segmentations that you most frequently hear about within the standards bodies. Now, we'd like to think about application segmentation as an overlay, which I don't think is discussed nearly enough. Understand, my lower right, we're talking about a cell which is primarily driven by Profinet. Well, there's going to be certain applications that are sensible to be communicating with that. So Maybe it's going to be a bunch of Siemens equipment. The S7 control apps probably are what should be there in place. And thus, I need to understand at a layer 7 perspective, what's the relationship between components and information that's going to be generated or acted upon in the cell and its recipients or control components up at the higher level. Again, not necessarily another set of PLCs, but just the workstations, historians that will work with that as well. Now, clearly there's going to be some cell-to-cell communications, particularly in a more serial process. But in this particular case, looking more towards what's the primary data flow and maybe more important, what controls the cell itself. So moving forward, of course, the big push we mentioned in 4.0, moving that information and telemetry up to the MES or ERP systems, and then eventually out to the cloud. Folks out at Siemens want you really to go out to MindSphere. GE wants you to go to Predix, and so forth and so on. So we keep extending these application boundaries and thus need the segmentation farther and farther away than, frankly, a lot of the original designs where we're thinking about. Now, a quick note on threats. We did an analysis and said, what are the applications that we are aware of at some of the factories that we've done some work at? And it was actually sort of surprising. The bulk of things that we saw within CVEs were overwhelmingly associated with the IT elements out there. Probably not too surprising because there's a heck of a lot more applications and componentry out in those spaces versus the explicit vulnerabilities that have been published for the OT equipment itself. Interestingly enough, the #1 OT vendor out there who actually had published CVEs was Siemens. If you looked at an analysis of their published vulnerabilities, a third of it is actually web interface problems or DLLs and such, basically meaning we're talking again about IT type asset issues that are basically driving the operational technology set. And we thought this was pretty interesting because sometimes we over-rotate on the thing aspect as opposed to looking at the full system. Finally, we look at this convergence, and hopefully it's not a collision, but a convergence between what's going on from a policy perspective from that factory DMZ on down with the desired communication stacks higher up. Eric made mention of the threat landscape and the fact that there's a well-known kill chain, something we work with on the security side all the time. Why not coordinate and share information about those phishing attempts that we see at that enterprise side, the communications that might be taking place from that connected outside world downward, and coordinating that with evaluation of logs and incidents that we see maybe at that DMZ firewall on down. We absolutely believe that if we're going to connect from the lowest levels of that process environment back up to the cloud, you are going to have to coordinate both with regards to security policy and security incident information sharing as well. Basically, the folks at the operational level and the IT level are going to have to cooperate because the bad stuff overwhelmingly comes down from the enterprise side, and that in turn is going to be hit by the outside world. People are going to have to coordinate. Now, I'm just going to make a really quick mention here. This one use case of remote access is an incredibly complicated story. The normal piece that most people say is, well, gee, I've got this technician, maybe it's ABB or KUKA or Fanuc or whomever. They're sitting at their tech center in Sweden, Singapore, Tokyo, Raleigh, and they need to gain access to this one piece of equipment that's in your plant floor, pump station, whatever the case might be. How do you coordinate that? What kind of policies do you put in place? Those of you who've ever worked with firewalls are probably aware that, yes, there's requests to put in pinholes into the firewall to allow someone to gain access. hey, this is the expert who understands this really expensive CNC machine. Our guys on third shift have no clue. We've got to allow them access as they need it. Great. But what if we went off with a different vendor and we decided to stop using, whomever, and we opt for, we're not going to use Fanuc anymore. We're going to stop using KUKA. We're going to switch one for the other. Did we remember to go back to the different firewall teams and say, hey, remember that information request that we put in for you to open up pinhole? We need to close that now. Generally doesn't happen. So that's a potential problem. The other problem that arises, of course, is that at some point that tech shows up on the plant floor. What are the policies that you have in place to account for what they can access, the conditions for them to even participate in the network itself? How do we go about doing all of those things? And this is something which is a very big challenge. How do we coordinate across all these different boundaries to ensure that the environment and the people operating in those environments are going to be kept safe? So, if anything else, there's certain things we really hope that you'll take some consideration is, as we said, have a plan. Understand the boundaries and who can provide the best help out there. So just to put it bluntly, if you've got IT assets controlling the operation of your factory, you might consider and ask the question, who best understands how to secure and keep operating an IT-looking technology stack? Right? Look at your network. Make sure that you have a sane, defensible network in place and you understand what all the different parts are that can communicate together. Look to the application level. We've got to get beyond just the physical connection and understand, gee, do I need SNMP to probe down into this level to understand the connectivity? Maybe yes, maybe no. I'm using What's Up Gold, whatever it might be. S7 should speak to what? The Schneider applications, talking Modbus, anybody else out there talking Modbus? Let's make sure that we understand that application level piece there. As we identify threats, again, think in a wider net. What are all the different pieces out there that we need to be considering from the perspective of this represents a threat, either something that could be deliberately manipulated or even just incidentally. Down is down. It doesn't really matter quite who did it or why in some respects, because anything that can be accidentally exploited basically can be purposely exploited. So just consider those things. It's always good to understand what the motivations and techniques that are behind a determined attacker, but don't leave yourself open to things for just incidental problems, because frankly, that's what shut down most of the major manufacturers last spring and early summer. And coordinate, connect, protect. You're going to have to work with people outside one individual organizational group to make these things happen. So consider the boundaries that your process environment is going to need to coordinate with. Think about that life cycle and start reaching out. And by the way, it's going to take years. That's okay. Right? Every long journey begins with a single step. Just commit yourself to moving forward. And that's the end of my presentation. If you've got some explicit comments or concerns about what I've presented, that's my email address. I would welcome the opportunity to communicate with you further. Lucian?
Thank you, Robert. By the way, that was Robert, product manager, senior product manager at Cisco with the IoT Security at Cisco Systems. And the session was on incremental steps that you can take to build a strong cybersecurity foundation and then build a greater secure connectivity. And next session it's gonna be focused around the cybersecurity for operations technology environment. And we're gonna have Richard Koo, Senior Vice President of Trend Microsystems, that's gonna basically give us a brief update on the business and cybersecurity challenges in the new convergence between IT and OT, with discussion surrounding best practices as well as recommendations. Richard Koo has over 28 years of hands-on experience working with high-tech and cybersecurity industry in a number of leading roles, as individual engineer, threat researcher, and management of a security product group across endpoint, server, email messaging, email gateway, and cloud, as well as software as a service. Currently, Richard serves as the Senior Vice President of Trend Micro IoT Security Business and is responsible for sales and market development for Trend Micro Security Business in the Americas. Richard has had an extensive experience and knowledge working with developing security products and services for multiple segments of the market, from consumer to small business and some of the world's largest enterprise. Richard?
Thank you, Lucian. Can you see my slide?
Yes.
Okay, great. So good morning and good afternoon or good evening, depending on where you're calling from in the world. Again, my name is Richard. And, the beauty of the evolving technology is that, we have, this have make it very easy for us, right, to do business, right, anywhere in the world, regardless of your physical location or devices, right? And as all the previous presenter talk about, right, because of this transformation or this digital transformation, right, you have created tremendous opportunity for us to do business. But at the same time, right, have created, a lot of security, challenge for enterprise customer, right? And when I talk about enterprise customer, it is in the context of the IT and the OT, right? That convergence, right, that is happening during this transformation. And so, a lot of conversation, will be focused on the operational technology, environment. Well, all we know, and I think as we all know, right, very well that, we have been very good in understanding how to secure the IT environment. And that's what every organization have been doing for the last, I would say 25 to 30 years, right? But, one of the things that we don't talk and discuss enough is, what are the, strategy and, policy that you need to put in place, right, in terms of securing the operational technology environment or the OT environment when you have this conversion from the IT and OT. So that's something that, we all need to think about, right? So on the next 30 minutes, I will talk you through some of the topics in the state of the digital transformation, some of the business challenge facing enterprise customer as they're going through their digital transformation and the process of converging the IT, OT environment together. And, Robert, previously mentioned about, that as well, right? So we're going to spend more time on that. And then I will also review through some of the risks associated with the OT environment, and will provide some guidance and best practice to reduce some of these risks. And we'll talk about some of the different categories of technology and how it can be applied, properly into the OT environment. And, maybe some guidance on some best practice to help vendors and organizations such as yourself to plan your security strategy and also part of your, digital transformation. So this particular slide, right, show the three significant changes in the IT, OT infrastructure over the last couple of decades, right? And how each of these changes have created significant business opportunity, as I mentioned before, for individual and also for organization. But at the same time, right, also create, a big opportunity for the cyber criminal, right? And from my perspective, right, the first phase of the, big infrastructure change that really happened somewhere between, around the early 80s to the early 90s, right? And this is where you have most organizations or individuals are very much kind of like using desktop server, right? They are standalone PC, right? And, they're running operating system at DOS and Windows and Novell and stuff like that. And, the type of threats are, as, Eric previously mentioned, right? Most of these threats are really more boot sector virus, and they are really more nuisance, right? And created by maybe laboratories or research or kids, who want to experiment with, so we didn't see a lot of challenge in terms of cybersecurity, right? And then, of course, in the second phase, right, that's really kind of begin, around the, early 90s to, I would say early 2000, right? And I think this is where, we see the internet are starting to take off, right? Organizations are more connected and interconnected together, moving from a client-server architecture to LAN, wide area networks, and then to cloud and virtualization and SaaS and so forth, right? And this thing, I think, is still happening today, right? And that is not finished yet, right? But, and this transformation is still going on, right? And especially the virtualization in the cloud and SaaS portion, which, we have seen. But at this phase, right, this is where you see some of the biggest cyber attack, right, and some of the sophistication of attacks is happening. And Eric previously mentioned, on the traditional, I would say IT environment, you have all the different threats, like in the early middle 90s, where you see mass mailing virus, like they're affecting the email server, like Melissa and I love you and stuff like that, which really kind of crippled down many communication for business, right? And then, of course, today, in the last couple of years, you see threats such as, WannaCry and, some of this ransomware were really kind of taking control and really affecting organizations across the globe, right? From healthcare to basically to manufacturers and to, retail and so forth. So, and have cost, organization millions and, hundreds of thousands of dollars in terms of cleaning up or maybe the downtime, right? And so this is what we see from, digital transformation from the second phase. And then, of course, finally, I think that the current phase that we are, or the industrial 4.0, and this is where you have this big infrastructure chain where, IoT and industrial Internet of Things are really making it, I would say, entrance into the many organizations across both the enterprise side as well as on the, operational side, right? And, and this is where you see, many adoption in terms of IoT devices, right? And of course, Eric earlier mentioned about some of the type of attack like the Ukrainian or some of the, attack, like a Mirai, right? Back in 2006. And those are, just as, I would say, many example of what we have seen in terms of, cyber criminal attacking, the industrial or the OT environment, right? So that's kind of the three phases that I have seen in terms of the big digital transformation. And, as I mentioned earlier, right, anytime any of this shift or this phase infrastructure change, right, we definitely see a very, good opportunity for many of the cyber criminal, right, to really take advantage of this digital transformation. And here, this particular, diagram kind of show, some data point in terms of how many connected devices out there, by 2020, right? Depending on who you, talk to from an analyst perspective, but there's some data points from Gartner, and you can see that, from a IoT adoption, across the consumer and business and, on a different cross industry or the vertical, consumer is still kind of the bulk of the adoption of IoT devices, right? And you can see business cross industry are starting to adopt that. And of course, some of the verticals such as healthcare or maybe manufacturing, or they are also starting to adopt, right? IoT, technologies and devices. What are some of the, business challenges in this new industrial digital convergence environment, right? From my many conversation I have with customer and partner, right? And here are some of them, right? So Eric and Robert kind of talk about some of this already, but I do want to briefly mention, right? We do see more and more OT domain really rely on the IT, cybersecurity deployment, protocol and knowledge for their daily operation, right? Because the OT side does not have the knowledge, the skill set, and the people to really address cybersecurity. So we start to see that that's a big challenge for many organizations because of the lack of skilled people, from a cybersecurity perspective. The other thing is that the decision maker, right, are now requesting more and more real-time information and access into the process data that require that increasingly internet connectivity between the IT and OT environment, and how to provide this information in a much more reliable way, but also safe, right? That has become a challenge, right? For many of the OT and also the IT organization. And of course, some of the other challenges like that, the business operation disruption or reputation damage or loss of intellectual property due to cyber attack are becoming more challenged due to the internet connectivity and compliance and regulation that also have played a very critical role in this, for many of the organization. And last but not least, right, there's the infrastructure and the domain knowledge to secure the OT and IT environment is lacking today because security strategy may not necessarily, right, incorporate it into the overall business plan or the overall security strategy, right? So these are some of the big challenges that we are seeing from a business perspective. So what are some of the risks and why, right? This diagram shows the evolution of the industrial environment and the maturity security model associated with each phase of that evolution, right? Starting from industrial, 1.0, right, to 4.0, right? And as you can see, as the industry, transform, improve, and increase its automation, connectivities, and the complexity of the network, right? We also see an increase in risk and sophistication of a cyber attack. And so as a result of this, right, it has created a tremendous risk for organizations across the world, and to do business. And these graphs show the operational risk and hourly cost for server downtime, right, in a different industry. And these are just some of the list of the industry and vertical that we're seeing, right? But once you start to really deep dive into, industry, critical infrastructure industries such as power and gas or oil, and then the operational cost and the risk associated with it, it's even bigger, right? Besides, the risk associated with business in the industrial environment, many critical systems can be, very high, and also the risk can be, cost people a life, right? And so that's what some of the risks were. And so I'm not sure if you're aware of some of the, incident like at the WannaCry attack, like last year, right, where many organizations such as healthcare and manufacturing were shut down, right, for weeks due to the lack of security planning on the OT side, right? And I think, Robert kind of mentioned this also, where in many cases, in some of the incident last year was the adversary or the cyber criminal were able to access and gain control of the IT side and perform lateral movement over to the OT networks. And there they basically crippled down the operational side of the organization. And that had created a tremendous cost in terms of the downtime for many organizations. So, we are aware of some of the security challenges, right? On the IT environment like cloud, data center, email server and web, and but what we don't talk about, as I said before, is the area of security challenge on the OT environment. And from my perspective, there are a couple areas on the OT environment that the security need to consider.
It's 11 o'clock.
On their security strategy, right? For example, the first one is the platform level or the middleware or the edge server, right? And we see this across both some of the new, IoT platform like Microsoft Azure or IoT or, Amazon Greengrass or some other independent third-party IoT platform, right? And some of the challenge there will be something like the potential of IoT platform being hacked, right? Or the tampering and manipulation of the platform. The configuration change on the platform can potentially affect security. And vulnerabilities in software update, right, on the platform can be a potential risk in terms of security. And then at the device level, right? And Robert kind of mentioned this, is that we see security challenge at the device level as well, right? Because many devices doesn't really think about security when these devices are being developed, right? And so things such as device tampering, impersonation of device, right? Or device hacking or snooping, right? Or any type of component firmware update could cause a problem on the device itself. And even vulnerabilities or insecure password on the device, right? And then what about in the cloud and the SaaS, right? Any compromised data lead to equipment damage or regulatory issue and personal safety. And that can also be a big, there's a lot of security challenges there. So even though securities today are put in place for cloud in some of the infrastructure, right? But when people start to move this into the operational side and really adopt IoT device and technology, we are seeing this. What about some of the protocols and operating system application, right? Like, for example, insecure networks and device protocol, vulnerabilities in the application or in the operating system. And the open network ports, insecure cryptographer, right? I think a lot of people kind of misunderstand that, hey, I have encryption and through my communication, I'm safe, right? What you need to think about is also the content itself, right? You need to make sure that the content that traveling through that communication are also clean and is secure and is not being manipulated or being changed, right? So that's something you need to think about. And last but not least, even as I mentioned, our traditional type of threat that we have seen, right? The malware, the ransomware, and the phishing, and the bots and the APT attacks, those are also a very big challenge on the OT environment as well, right? So don't think that because it's only affecting the IT side and it's not going to affect your OT side, and you need to really look at that. This is just a couple, an example of, and if you have access to the internet search engine Shodan, right? You will be able to do some search and you can see that, the number of exposed, medical healthcare device or any other verticals that have been exposed to the internet, right? And even though they are not vulnerable, right? The potential of the, cyber criminal gaining access to it and, potentially compromise that device and then gain access to the networks, that potentially can happen, right? Or, your cyber criminal can take control of some of these exposed, IoT devices, right, in the corporate network and use that as an attack, bots or something like that, right? So, you can actually go out there, you can look at a Shodan website, you can search and see any of your particular, IoT device and actually have been exposed. And this is just an example of that. And, why is that, the cyber criminals are so interested, right, in gaining access to some of, this, data, this information in the enterprise, both on the IT and on the OT side. You can see here, right, profile with social security number, right, you can probably pay for that, right? And if you have access to, let's say, birth certificate, right, that's $500, right? And if you gain access to a complete, let's say, HR database, right? That's $500,000. You can see that it's very lucrative and it's very profitable for someone in the business, cyber criminal. That's why they are so, I would say, into, gaining access to the organizations. So how do you reduce risk? Again, I think, based on this maturity model, right, organization can reduce the risk by increasing their visibility across both the IT, OT environment, right? Increase the prevention across both environment on the IT, OT side, and make sure that the detection and improve a security control, across both IT and OT. And there have to be a level of, I would say, response and process that put in place, and across both environment. And also Robert mentioned about the increased collaboration between the IT and OT organization, right? And learn some best practice, share knowledge, from each other and how to minimize some of the risk across both environments. And this hopefully will resolve into kind of minimize some of the organization being attacked or, reduces some of the risk. Now, this is some, not necessarily a silver bullet, but these are some good best practice, and also a baseline. Next, one thing that, we talk about is, security is all about people, process, product, and technology, right? And I think you need to really have all those together. And so, with any cybersecurity strategy, right, a baseline security risk management framework, right, or lifecycle management is a must for every enterprise IT and OT organization. Such a cybersecurity framework enable organization, regardless of size or degree of, cybersecurity expertise or sophistication, to apply this principle of best practice can really help improve the resiliency in critical infrastructure, right? Sometimes this kind of cybersecurity framework has to be customized, right? To your environment or to your own organization, right? Because of the nature of your business or the ecosystem you're in, and maybe your competition or the threat that is unique to your environment. So you need to kind of make sure that kind of customize. And, of course, some of the essential security framework, it's more like a, working document. You need to continue to evolve through the learning process and real work experience, because security is not a, stand still, right? It's a continuous, and you need to make sure that framework continue to be evolved, right? So, cybersecurity risk management framework consists of kind of, to me, like a 6 phase, right? Phase 1, starting with, identify and understand the threat, the capability, risk, the organization, system, and assets. And then phase 2, how to prevent and ensure that these critical system and assets are safeguarded against such attack, right? And make sure that it continue to be available and resiliency of this critical asset. And how to identify and detect occurrence of the attack. Phase 4, what kind of action and response the organization need to take against this type of attack, and what type of plan an organization needs to implement, right, for resiliency and recovery from such an attack. And then finally, if you have all this in place and all the, I would say, information in place, it should help you to kind of anticipate and predict what could happen, and can provide some early plan to put that in place, right? So this is kind of the baseline cyber risk management framework that I think you can utilize, right? And of course, the other thing is designing and having a sound foundation of your IT OT networks, right? To understand risk, right? This diagram kind of on the top kind of show the enterprise side of the information technology or the IT side. And then on the middle and to the bottom, which is the operational technology environment. And you can see here, by having a good understanding of your foundation of your networks, where all the asset, where all the network connectivities and the application are, you will be able to understand what technology that you can apply across some of this, and what are some of the risks associated with each layer of the model, right? And then, because what kind of threat that could potentially impact on that network environment. So that's a fundamental, I think, every organization need to understand. And of course, you can reference, right, some of the industry best practice. For example, right, this is the ISA 95 reference architecture that anyone can actually reference, and it provides some good guidelines on how to apply security, and control and policy, right? And you can refer back to the ISA, 62443, or even some of the NIST framework. Those are good security reference architecture that I think you can actually apply across both your enterprise side as well as your OT environment. And this is a typical, I would say, in IT OT security reference architecture. that kind of map to that, ISA reference architecture. And you can see here you have your traditional IT environment on the right side from endpoint right to this, basically server to the email and then into the cloud, right? That is typically what we have been securing and, that environment for the last 30 years. But on the left side, that's the side where we have a lot of concern as you go into this digital transformation, right? And you need to be able to make sure that you have some level of security applied at the IO or at the device level. And then of course, at the control level, you see many of these are Windows system like HMI machine or SCADA's computer, or it's RTU or DCS system, right? They can be, security can also be applied, right, across that layer. And then of course, at the supervisory level, these are typically your, your traditional Windows system or Linux system. And this is where potentially there's a lot of risk in there because, depending on how your organization or your network infrastructure is set up, right, for some people, right, there's egress and ingress point between IT, OT environment, and you can potentially apply some, security solution at that level to basically monitor and check for east-west traffic or north-south traffic, right? And you can lock down all this control environment using some type of it's a whitelisting product as well. And then at the device level, right, we recommend that security be baked into as part of the device manufacture process, so that you can, as the product are being developed, security is built in, and when it's released to the market to the end customer, right, security already been baked into the product, right? So this is just a typical IT OT security reference architecture that you can refer to and how this can be applied to your organizations. I'm not going to go through this, but I think some best practice guideline for any enterprise organization is your vision and strategy, right, in the execution of your business plan need to include security, reliability, and safety into that plan, right? It's not and should not be an afterthought, right? On the OT side, security policy, governance, and end user education need to be extended across IT and OT environment, right? It's not just your old IT only, but it needs to go across. Baseline security control and security framework should be deployed across all layers of the organization, right? And as I mentioned, right, organizations should consider standards such as NIST 85310 for IT and then NIST 800-2 8211 in ISA or IEC 62443 standard for OT. I think these are good reference that you can refer to, and that can you can adapt that to your organization. Regular risk assessment across the environment, it's important to identify any type of vulnerabilities and ensure the security control are put in place. And establish or update your security patches, right? And there's some process and standard layout in the 62443 from IEC that you can use. And develop a security policy and procedure that are consistent across the IT and OT environment to ensure the physical safety and the business continuity and the resiliency of your operation. And one thing is that technology and threat across IT, OT should be clearly understood, right? Technology that work in the IT environment may not necessarily work on the OT or some of the biomedical environment. And we are seeing that, right? Where organization will take an IT product and they try to basically perform some kind of scanning or vulnerability assessment on the OT side, and that can potentially cripple the whole networks, right? So that's just something to think about. Some of the technology, to think about in terms of category, risk assessment tool, right? Next generation IPS, technology. Many of the threat, protection solutions today can still be very applicable, right? Everything from your traditional anti-malware to ransomware protection, APT, and phishing attack is still very relevant. Whitelisting and lockdown software, those are important, right? Vulnerability scanning and patch management tool, right? And so these are some of the examples that you can, consider and make sure that you can test it and apply and make sure that it can work across both the IT and OT side. And some of the things that you should be considering, when choosing, a vendor, right? Does the vendor really understand security associated with both the IT, OT, right? And you make sure that they have that, because as I said, right, an IT product may not necessarily going to be working well in the OT environment, and that could do more damage than good for the, the organization. Does the vendor, have a track record of proven technology that can work on both environments, right, as they go into this digital transformation? And is the vendor evolve, their technology to deal with some of the threat and some of the sophistication of this conversion between IT, OT? And is the vendor going to be around, for the next, couple years, right? You don't want to choose a vendor that has they got a nice, great product, but it's going to be good for the next 12 months, and then, next year you won't be able to find that vendor because they went out of business, or they've been bought, and that could be some challenge for you. So just something to think about. So some key takeaway, right? Understand the business security challenge facing your organization holistically across both IT, OT. Understand that your IT security solution may not always work, on the OT environment, and you need to perform some of the, assess and follow industry best practice and recommendation. Be proactive in keeping your organization up to date in the latest cyber threats and security technology. And the threat is real in the OT, right? So don't wait until you're being compromised and you start looking for a security solution, right? Because that is too late. So, and some of the things to think about, some of the threat to watch out for, in the second half of this year, right? Some of the things we're seeing is that the threat actors are riding on machine learning and blockchain technologies, and they want to expand the evasion and techniques and the sophistication of attacks. So be aware of that and look at that. Ransomware will continue to be a big thing in 2018. So be aware of that. We've seen that in the past. And of course, global loss from a BEC scam, have also, created a lot of, I think, a challenge for many organizations. And some of this GDPR that had recently, been, enforced in the European Union, right? I think that's something you need to also think about, right? Because the first high-profile lawsuit, when that happened, right, I think every organization will start to really look into. So it's good to start that early. And in enterprise, industrial IoT application and platform will be at risk, of manipulation or vulnerability, as I mentioned before. So these are some of the things to watch out for, and partner, right? And talk to some of the industry leader out there, right? Like I say, some of the standards, the Department of Justice, and also some of the, Homeland Security. They have different type of security standards, different type of framework out there. So depending on what verticals you have, you can actually go out there, and a lot of this information already available. You don't have to rebuild or create all this, framework or some guideline. It's already out there, and you can adapt that to your environment. So I think that's my presentation. Thank you, and look forward to answer any questions you might have. Thank you.
Thank you, Richard. And there was Richard Koo with Thread Microsystems, Senior Vice President. And we're now inviting all panelists for the last part of the virtual conference. If you could please unmute yourself. We're going to bring Greg Orloff, the Chief Innovation Officer of IoT World. He has served as a CEO of Tangent Company, has got a background in engineering and a master's degree in business administration from Case Western Reserve University. Greg, welcome. And right now we're bringing back Eric Byers, as well as Robert Albach from Cisco, and Richard Trent from your questions. And again, we have a limited time here, but we're trying our best to answer your questions, and then we can take the conversation through the Twitter and LinkedIn.
All right, thank you, Lucian. But just a tremendous thank you to Eric, Richard, and Robert. That was a tremendous amount of information to digest, and based off of the response that we've got, you've got a whole bunch of questions, and there's a lot of interest. So we're going to work through these as quickly as we can, but I do want you to know we've captured all of the questions, and we're going to carry this conversation over to social media, and someone will be back if we don't get to field these live. So having stated that, let's start off. There's a question that came in from Ravi said, how would an OT guy know what weaknesses exist in the firmware? Eric, would you like to address this question?
Sure. This is one actually that's really near and dear to my heart. My company, Adolis, is actually doing research for the Department of Homeland Security on how you answer this question. The problem that we see is, and it's very legitimate, well, the easy answer is, well, go check with the vendor. That's a lot of work, especially if you have a lot of vendors, and it's not always complete. So we've been working on a project for the DHS to build a ecosystem that basically gives a one-stop shop where you can come and look at inject a piece of or submit a piece of software, and it gives you back a report on everything known about that software. Was the vendor reporting anything? Was NIST reporting anything? Did it really come from the vendor, or did it come from a hostile nation state, et cetera? As much information as currently available. Obviously, it can't predict the future. This, of course, is a research project and still in development, but if anybody is interested in getting involved in trying it out, but you nailed it, Ravi. That's a tough question. Ravi also asked a second question, which is pretty relevant, I think, to the same thing, to the same problem, which is how is whitelisting done without electronic signatures and hash values in legacy devices? And again, it's not. There's not much you can do as far as, say, whitelisting software in a PLC. What you have to do is be whitelisting what is going into the PLCs. So you could be doing that with tools that, well, first of all, good policy that has the deployment team validating and being sure that they're loading the right software first or the right firmware. And then you can also overlay tools, some of the network analysis tools, et cetera, will show you what files are actually being transferred on the network. And as part of our research project, we're actually working with one of the network anomaly detection companies to actually, they'll do an interception of a file, and then we'll say, hey, that's firmware that was released by Rockwell. It's valid. It's this version and has this issues, and report that back as part of their, allow them to report it basically. So there's a lot of research going on this, but the quick answer is we're still working on this problem. Right now, the best way you can do is really through your manual processes. Hopefully by this time next year, that'll change.
Great, thank you, Eric. One other question that came in, it says, does Cisco have version control or modification for applications protected at the OT side? Robert, would you like to address that? You still with us, Robert? Okay, maybe we'll circle back to that question in a second then. Sumit had another one here. It says, how does enterprise SOC integration help if alerts are sent to them? Question mark. So does anyone of the panelists want to try and field that question for Sumit?
Can you repeat that question again, Greg?
Absolutely, yeah, not a problem. It is, how does enterprise SOC integration help if alerts are sent to them?
Well, I think,
could. Oh,
yeah,
go ahead.
Robert. Go ahead, Robert. Oh, Eric, you want to go ahead?
Yeah, sure. I can tackle that one first because I've worked on a couple of integration projects. I think it was Robert who mentioned earlier, maybe it was Richard who had said, that the attacks come from the IT department. I mean, sorry, that's the way the world works. That most people attack using the IT department or the IT services as a stage. You get very few attacks, not none, but when you look at all the successful attacks, Stuxnet, Shamoon, et cetera, the Ukraine attacks, bad stuff comes from the IT environment because that's the easiest area to penetrate, the most exposed or the most obvious and the most complex. And so in it comes, you really need those alerts going two ways. You really need an integrated model because if the enterprise SOCs can understand and correlate, and again, I'll go back to my model building, they can correlate that, oh, a device over here that's had some unusual behaviors is now trying to send Modbus messages down to this controller, and then this Modbus controller is generating alerts that's getting sent back up to the SOC. They get a big picture view. A friend of mine who used to be the head of security at Dow used to say, there's never a leak just in your end of the boat. And so it's really critical that the SOC guys can see what is happening down in the control system. But it's more complex than that too. And this is again where I talk about models, is just because you've got an event doesn't mean it's a bad guy. You really have to decide in your, again, in your model of what's happening, where or what is causing that. You know, you may see, for example, some bad Modbus, well, I'll go back to Modbus because it's so common. You know, I saw some bad Modbus behaviors in a control system that were reported by a network detection system. And everybody was panicking because they assumed that there was an attacker in there and the messages were going up to the SOC, or the alerts were going up to the SOC. This is great, but this is where your model of, hey, wait a second, what are those things really? It turns out that actually it was the secondary controller on a primary secondary backup defined system that had gone off the rails. And really the person that needed to fix this was the controls engineer down the floor. He was no longer running a redundant system. He was running a primary only system, and the backup was hooped. Here's some really valuable information that's coming out of security that is available to the SOC, but you've got to understand how to feed that back to the people who really need it. So it's not always just about getting data to the SOC. It's also getting enterprise SOC information back to the plant floor so they can act on it, either to help support a defense or just fix things that are busted.
Yeah, and
actually, this is Robert. I'll just maybe jump in on this because this is actually one of my favorite examples. I'd suggest not just focus on the SOC per se, but also think about the NOC as well, because some of the behaviors that you'll see will actually manifest within the network observation, which I think Eric was just mentioning. One of those, I think, Eric, you actually did this demo of, here's someone squawking in port 502, and it's from the outbound world, and it looks like it's trying to traverse the firewall down into the factory. We had exactly this literal thing happen, and what we discovered was that a lot of the UPSs, right, the power supplies, the backup power supplies for the data center, are actually controlled by Modbus. So actually, at the enterprise side, we had Modbus traffic buzzing around, as it should have been, because they were basically taking the health state of these backups. Now, normally they weren't on the general network, and for some reason, somebody did a typo, and it ended up trying to reach something that was resolving down to the factory environment. But a lot of people panicked, but in fact, this bi-directional communication probably would have helped, understand, first off, what was this 502, and it ended up hitting down the factory, and they thought, oh my gosh, we're being attacked. And then, eventually it was in fact the data center IT guys that said, oh no, that's just our UPSs that are, out there squawking on port 502, as we expect. So I'll leave that. Richard?
No, I mean, I think you guys covered most of the topic, but, again, I think that the key is you have to fully have a holistic view, right, of the entire organization, both on the IT and OT side, so that you can have, complete visibility. If you look at that risk model, material risk model that I presented, right, if you have better visibility across the two environment and your prevention or detection response, you're definitely, you're going to have a better control and reducing the risk. So I think to Robert or to Eric's point, right, I think all these have to come to play, and you have to look at everything holistically. Otherwise, you're going to, the bad guys only have to get right one time, right? And we have to get right every time. And so the more tools, the more technology we have, across these two environments and make it available to the, security team, it will, only better off and help us to minimize those kind of attacks.
That's great. Thank Richard. Thank you. There's another question here that's kind of in line with that last comment you just made, and it's from Sundara. It says, how can I understand an intruder is on my network? And then the follow-up is, what tools are available to stop intruders, and are these tools freely available? Would you like to field that one?
Yeah, I mean, I think, as I mentioned, right, in terms of tool, on the presentation I presented, there's a whole slew of tools that are available out there. But the key is to make sure that, those tools are developed in such that we'll be able to work on the, OT networks, right, as well, because, and there, things such as, network, IPS product, from different vendors, for example, here in Trend Micro, we have a product called, Tipping Point, right? And that is also a good IPS product that allow you to basically set between the east-west traffic or north-south traffic, right? And you can potentially, detect all this intrusion coming through your, OT networks on the IT side, or even on the OT side, right? North-south traffic, you can actually monitor all the traffic. So there are some tools out there, but again, the key is to make sure that these product and technologies are designed in such that we'll be able to monitor different protocols or different type of, traffic that coming through, because, many of these traditional or, existing, let's say, in industrial devices, right, not necessarily using TCP/IP, right, they might be using Modbus and stuff like that, and so make sure that those, tools are able to monitor those traffic. But there are some of those out there.
Excellent. We've probably got time for one, maybe two more questions. This is more of a, I guess, a broader spectrum one. I'll throw it out to the group. There's a comment from Paige. She said, good discussion. Well, thank you, Paige. I'm glad you're enjoying the session. How does the move to wireless affect strategy?
I'll tackle that. I'll tackle that one real quick. Ultimately, it really doesn't. I mean, wireless is just another pipe to move data around. It has its own little idiosyncrasies, but in some cases, in my opinion, wireless is actually more secure because people than wired networks, because people actually thought a little bit about security when they put particularly field wireless systems like ISA 100 or wireless HART. There's actually some engineering that went into the security before it got published. So, ultimately, I think you want to look at the whole problem holistically. The other, Richard and Rob might disagree with me, but really it's the big picture that matters rather than the way you're moving the bits.
Yeah, this is Robert. I'm going to have a slight variance on there. Planned wireless or wireless you purposely installed should not be a problem. Now, if wireless that somehow just showed up in the machine when it first showed up on the floor and you didn't plan to put it there, you'll see problems with that. Sometimes you'll have some cellular modems inserted in there, in which case someone can bypass every security structure that you've tried to establish over time. So if it's purposeful wireless projects, fully agree. I think in many respects, in a way that they're more modern, they're more recent, and they're more likely to have been purposely planned there. I do cast a very jaundiced eye, though, when I discover that there's convenience wireless access points that have just been incidentally or surreptitiously inserted in some places, maybe either not purposely pulled out or accidentally left on, or whatever the case may be.
That's spot on. I'm going to agree. Yeah, planned wireless. This whole accidental wireless access points is reminiscent of the days when I used to have to deal with 1200 baud modems that got stuck in control rooms.
Yeah, one thing I just want to add to the wireless conversation is that I think depending on the verticals you're at, right? I think when you go to the verticals such as maybe industrial controller, maybe power and energy and stuff like that. Maybe the wireless may not be there yet, right? And wireless may not yet connected directly from say a device to the OT networks. But in other verticals such as healthcare and maybe retail, right? You do already see organizations adopting wireless device, and they may connect directly to the cloud, right? And so there's a potential of risk, right? Or if they're adopting, say some of this new IoT platform, right, where most of the components are, on the device, but then they are connected directly to the cloud. And unless you have, full control of the device itself and you secure it, or if you can secure it, also you have to secure the cloud, right? So wireless could potentially become, another attack vectors. And, and again, I think you got just to plan and look at the big picture, right? Anything connect to your network, regardless if it's a physical device or wireless devices, right? They have to be secure. Communication has to be secure. The contents have to be secure, right? And where is it delivering that, information to, right? Is it the cloud or directly into the data center or into the operation network, right? Everything has to be secure. So more of a holistic view, but also more of a defense in depth solution and looking at everything. That's including your policy, right? Definitely, it will become an issue, and will have a security implication for sure.
Excellent. That's good insight. Thank you, Richard. I think we'll throw one more question out to the group. This is a loaded one, but how will cybersecurity solutions impact insurance rates? Is there a good study out there that anyone's aware of? This is from Emil.
Hey.
This is Robert. So we actually have partnerships with Axion and one other entity, I believe, specifically around security and insurance rates for corporate environments. So sorry to not know more of the details, but certainly this is a project that we announced. We worked very closely between our security group and the insurance industry on what it is that we could do to help reduce, from the insurer's perspective, losses they would have to cover, and of course from the insured's perspective, things that they could do to improve their security state.
Excellent. Thank you, Robert.
All right. Thank you, everybody, for joining. Thank you, the speakers. Thank you, Eric Byers, Robert Albach, Richard Koo, and Greg Orloff for the insights here. And stay tuned for a few other virtual conference that we have scheduled around critical infrastructure, as well as securing on chip with Intel in September 18th, as well as several other ones around predictive analytics for manufacturing, as well as taking a vertical approach such as security, food and beverage, and so on. So with that, just keep in mind that we can continue the conversation on Twitter, hashtag ICS_IoT. And thank you for this. You will have an email with the recorded session in case you miss any parts of this virtual conference. With that, this concludes our virtual conference. Thank you so much. Have a great rest of the day, and thank you for sticking around the extra time.
Thanks so much.
Thank you. Take care, everyone.